Okay, ladies and gentlemen, today we are going to go back over the Pythagorean theorem, which I know we have visited multiple times this year. We are also going to talk about the converse of that theorem, which is useful in determining what type of triangle we're actually looking at. So let's start with the Pythagorean theorem. Again, it's used in finding the missing sides of a right triangle. Sides A and B are actually called the legs of the triangle. They are the two that touch the 90-degree angle. Side C is called the hypotenuse. The hypotenuse will never touch the 90-degree angle. It will also always be the longest side of the right triangle. For any right triangle, we should know that a squared plus b squared equals c squared. Okay, we'll keep moving forward. I'm going to focus on the odd examples today. I know that we've visited this multiple times. We are going to add in some word problems. So I'm going to focus on the odd examples. I will post an answer key of the even examples. Okay, so if we look at example 1, the first thing that I can tell is that the two that touch the 90 are 8 and 13. So if I look at my formula, a squared plus b squared is c squared. So 8 squared plus 13 squared should equal x squared. And if I do those figures, 64 plus 169 should equal x squared. So if I combine the like terms, I get that 233 is x squared. And so now I want to get rid of the x squared, so I'm going to take the square root of both sides. And I should get a final answer of 15.3 as x. Today we are going to round our answers to the nearest tenth. Okay, if I look at the next example, we're going to look at example 3. So again, my formula is a squared plus b squared equals c squared. So I see that the two that touch the 90 are the x and the 7. So that's going to make my formula fill in with x squared plus 7 squared equals 9 squared. Whenever I do the squaring, I've got x squared plus 49 equals 81. At this point, I want to subtract the 49 from both sides. And so now at this point I should have x squared equals 32. Then if I take the square root of both sides, I'm going to get that x is 5.7. Again, rounding to the nearest tenth. Okay, I'm going to keep moving forward. Example 5 is a little different than what I've seen in the past. Something that I know here is that because the two sides are congruent, in other words, because I have an isosceles triangle, and this line drops straight to the center, it actually creates two equal pieces, which if I then measured those two, split 22 in half, each of these would be 11. Okay, so again, my formula, a squared plus b squared equals c squared. So if I fill it in, I've got x squared plus 11 squared equals 24 squared because the x and the 11 form the 90-degree angle. So whenever I square, I've got x squared plus 121 equals 576, which I would then subtract 121 from both sides, which leaves me with x squared is 455. I'm going to then take the square root of both sides, and I get that x is 21.3, again rounding to the nearest tenth. Problem 7. I actually am going to split that side that's called x into two pieces, and I called them y and z. So then I'm going to find both y and z, and I'm going to add those together. So for y, I've got a squared plus b squared is c squared, which means y squared plus 12 squared equals 14 squared, or y squared plus 144 equals 196. So then I would subtract 144 from both sides, which should leave me with y squared equals 52, and then I take the square root of both sides, and I should get y is 7.2. Then I'm going to go to the other side and find z. So again, I use my formula, a squared plus b squared equals c squared. which in this case would be z squared plus 12 squared equals 29 squared, which is z squared plus 144 is equal to 841. Subtract the 144, I'm sorry I did not show that step. Subtract 144 from both sides and I should have z squared equals 697. Take the square root of both sides and I should get that z is equal to 26.4. So then I want to go back and I need to find that x. So in my mind I think that x is y plus z, or x is equal to 7.2 plus 26.4, which should give me that x is approximately 33.6. Now this is not exact, but it's pretty darn close. Okay, if I move on to example 9. On example 9, this is what I know. I know that the base is 40 and that the top is 26. So I'm going to transfer that 26 down to the bottom, which is then going to actually create two equal pieces here and here. So if I take the 26 away from 40, that leaves me with 14. And if I divide 14 by 2, that actually gives me 7 for each of those pieces. So then I can use Pythagorean theorem. I know that if this side over on the right is 20, that means that this would be 20. So Pythagorean theorem, a squared plus b squared is c squared. I could do x squared plus 7 squared equals 20 squared, which means x squared plus 49 equals 400. So then if I subtract that 49, I get that x squared is equal to 351. Take the square root of both sides, and I get that x is 18.7. Okay. Now we're going to talk about some word problems. When I work the word problems, which in your examples are 10 through 13, the very first thing I want to do is I want to draw a picture because I want to know what I'm looking at. So on this example 11, it says that Kurt is building a rectangular deck. Okay, so I have a rectangle. It then says if the dimensions of the deck are 10 feet by 23 feet, what is the length of the diagonal? So you've noticed that I drew the diagonal in on my picture. I'm going to label my sides. So I have one side that's 10 foot, I have another side that's 23 foot, and I'm looking for the side or for that diagonal that should be x feet. So my right angle should occur in the corner of a rectangle. So I'm going to use Pythagorean theorem. A squared plus b squared equals c squared. Or in this case 10 squared plus 23 squared equals x squared. I'm going to do my squaring. 100 plus 529 equals x squared. So I've got 629 equals x squared. Take the square root of both sides. And I should get that x is 25.1 feet whenever I round this to the nearest tenth. I'm going to look at the next example. Example 13, I've got a triangle drawn here. It says a 31-foot support wire is attached from the top of a 25-foot telephone pole to a point on the ground. So my wire that runs diagonally is 31 foot. My pole is 25 foot tall. I want to know how far from the base of the pole does the wire meet the ground. So I'm looking for that x feet on the bottom. So again, this is a right triangle, so I'm going to use Pythagorean theorem. A squared plus b squared equals c squared, or x squared plus 25 squared equals 31 squared. So I do my squaring. X squared plus 625 equals 961. X is on the side added to 625, so I'm going to subtract 625 from both sides. So I actually get that x squared is 336. I take the square root of both sides, and I should get that x equals 18.3 feet. Okay, on the next page. So on this page, we're going to talk about the converse of the Pythagorean theorem. It says that if I'm given a triangle with sides A, B, and C, which we know that C is always the hypotenuse, so it's always the longest side. If C squared is equal to A squared plus B squared, then the triangle is right. If C squared is greater than A squared plus B squared, the triangle is obtuse. And if C squared is less than A squared plus B squared, the triangle is acute. It gives us a hint there to always keep c squared on the left side to avoid confusion when classifying. Another hint I want to give you is that we need to check to see if it actually is a triangle by adding together the two smaller sides. And remember that to be a triangle, that their sum should be larger than the biggest side. So if I add the two smaller numbers together, I should get some number larger than the biggest. So our examples, the directions state, first determine if the three side lengths could form a triangle. So recall from earlier that the sum of the two smaller sides must be greater than the third. And if yes, classify it further as acute, right, or obtuse. So my first example here says I've got side lengths of 3, 7, and 9. So I'm going to check. Is 3 plus 7 bigger than 9? Yes, in fact it is, because 3 plus 7 is 10. So 10 is bigger than 9. So then I plug it into the c squared, comparing it to a squared plus b squared. So is 9 squared compared to 3 squared plus 7 squared? Which means, what is 81 compared to 9 plus 49? Or what's 81 compared to 58? Well, I'd rather have $81 in my bank account than 58, so it's greater than. And if I look back at whether it's equal to, greater than, or less than, if it's greater than, it's an obtuse triangle. Let's look at example 3. Example 3, I'm going to do the same thing. The first thing I'm going to do is I'm going to check, is the sum of the two smaller sides bigger than the third? So is 4 plus 11 greater than 16? In this case, no, it's not, because 4 plus 11 is only 15. 15 is not greater than 16, so this is not a triangle. That's as far as I have to go. Example 5, again, first I check to see, is it a triangle? So, is 18 plus 24 greater than 30? Well, 18 plus 24 is 42. 42 is bigger than 30, so yes, it's a triangle. So then I start checking c squared compared to a squared plus b squared. So my c would be 30, so 30 squared compared to 18 squared plus 24 squared. What is 900 compared to 324 plus 576? And so whenever I combine those, I get 900 compared to 900, which is equal. And so then if those two numbers are equal, this has to be a right triangle. One more example. Example 7. I want to compare a triangle with side lengths of 31, 35, and 39. So the first thing I do is I check to see, is the sum of the smaller two greater than the third? So is 31 plus 35 greater than 39? Well, yes, it's 66, and 66 is greater than 39, so it can be a triangle. So then I compare c squared to a squared plus b squared. So 39 squared is compared to 31 squared plus 35 squared. Or 1,521 is compared to 961 plus 1,225. So whenever I combine those, I get 1,521 compared to 2,186. I'd rather have the $2,186, so 1,521 is less than 2,186. The less than symbol indicates that this is an acute triangle. Okay guys, that is the lesson for today. Make sure you go backwards if you need to double check any. Also, if you need to look at some that were like the evens on your notes, please make sure to check the notes, the filled in notes that are available through your Canvas. Have a great day.